Hello, everybody. Welcome back. Now, up till now, we have talked a lot about the kinds of changes that human beings are causing to the biosphere. We've looked at a lot of the functioning of the biosphere, and we've discussed how human activity is altering those functions. And we now need to realize that there is a group of scientists who decide on how to break up geological time, and they do so by looking at changes in the geological record. And there is a discussion at the moment about establishing a new geological epoch, which would include the time that human beings have substantially altered the functioning of the biosphere. And that time, this new epoch, they are dubbing the Anthropocene. Now, in order to define the Anthropocene, it has got to appear in the geological record, and it has to be generally visible in the geological record. And so I have to add a question mark to the title of this lecture, the Anthropocene, because it has not yet been decided that this is in fact the case. But many people make the argument that some of the changes that have been produced by human activity will indeed be included and visible in the geological record to future generations who examine the geological record. Now, let's have a look and see. Here we have the geological record as it stands at the moment. This is, by the way, a very simplified version, but all that we're going to be interested in is this era here in yellow. That is an era, and it is called the Cenozoic. Now, each of these divisions of geological time are marked by changes in the geological record, very often by changes in the fossils, reflecting changes in flora and fauna in previous times, especially looking at mass extinctions that have occurred, and then also at geological changes that have occurred. So this is the Cenozoic, and you'll see it's divided into epochs. And the epoch that we are most interested in for purposes today, first of all, it's called the Quaternary period, but it is divided at the moment into the Pleistocene and the Holocene. And the Pleistocene end, first of all, the end of the Pleistocene is marked by the end of the ice ages. And it's also the time, look at the number of years ago, about 12,000 years ago. You'll remember that this is about the time, in this time of climate change, this was the time when people began to settle down and become agrarian. They started performing agriculture. So this, from that period on, the end of the ice ages till today, is called the Holocene. And it's often referred to as the recent. So this is now the scientists are proposing that we actually terminate the Holocene and begin the new epoch, which is the Anthropocene. But in order to do so, it has to appear in the geological record as a distinct break. That is what all the discussion is about. So today, what I'm going to do is I'm going to discuss a number of really important global enterprises which human beings undertake, which have the potential for radically altering the functioning of the biosphere, some of which might well appear in the geological record. And that's going to be our discussion. This, I have to say, in many ways, a somewhat depressing discussion, because a lot of what we're going to talk about is actual damage to the biosphere. But along the way, I will try and suggest some of the solutions which might be adopted to ameliorate the damage. Okay, so there's not a lot of theory behind what I'm going to tell you about. I'm going to run through just these various aspects, but be aware of the fact I'm omitting a gazillion of different things. There are many, many other topics which we could discuss, but each of them could actually fill a lecture. So I'm just giving you a brief survey of some of the most important. And I will also refer you back to some of the things we have already discussed, which should form part of our discussion, but we don't have time for today. Okay, so we've affected the biosphere in many, many different ways. And the first thing to realize is that it's our tremendous population increase that has largely contributed to this. Remembering that we were only 1 billion people in 1800, and we are now close to 8 billion people on the planet. And that's a rapid increase in population number, and the demands that the population have placed on the biosphere has been tremendous. And that I'll give you one interesting fact, that the weight of human beings, the biomass of human beings, now outweighs the total biomass of all other vertebrates. And in addition, we have developed tremendous technological advancement, technological development, and we have gathered together in huge numbers in cities and towns. And those themselves represent a very, in geological time, a very, very new development. And they bring with them benefits, but they also bring tremendous problems that we will discuss. Some issues we have discussed already. First of all, global climate change, we discussed at length, and you need to go back and revise that to remember all those impacts. We have also discussed what is happening with global climate change. Global heating is warming the oceans, affecting, for example, current structure and ocean functioning and organisms in the ocean. We also discussed ocean acidification, as about a third of the carbon dioxide generated on the planet is absorbed by the oceans, and that is increasing the acidity. It's decreasing the pH. That's the way it's referred to scientifically, but it is increasing the acidity. Today, we will discuss a little bit of the overexploitation of the ocean resources, remembering that the ocean provides us with resources. So the other one thing that we will refer to briefly, we have referred to before, but I will refer to it again, and that is deforestation and agricultural development, because these bring with them particular problems that we need to discuss. Other things we have not discussed at all, and these are things like pollution, particularly production of chemicals which are released into the environment. These are also many things we are producing in modern times do not occur in nature. They're entirely artificial substances, and as a result, it's extremely difficult for them to be broken down biologically, and very often very difficult for them to be broken down by natural things like ultraviolet light and everything else that we might expect to break them down. These range from extremely toxic toxins, pesticides, which are causing ecological havoc by wiping out, for instance, the insects. Then we also pollute with nitrogen, phosphorus especially, and by doing so, we disrupt natural cycles of nitrogen and phosphorus with particular effects that I'll discuss later on. We also produce these substances called plastics. There are many kinds of plastic, but most of them have the characteristic, first of all, that they're completely artificial. They are not, almost without exception, there are one or two that are biodegradable, but they are almost without exception not biodegradable and very long-lived in the environment. And sometimes when, I will point out now that sometimes when they say they are biodegradable, they're not actually biodegradable, they just break up in the environment, especially in the influence of ultraviolet light. And they just break into very small pieces, which we can't easily see. And those are called microplastics. And microplastics are a huge problem. We also, particularly as the population has got so huge, and especially in cities, in these huge cities, There are huge problems with the amount of waste that we produce. That is not only trash, plastics that we use once and throw away, uh, waste food, etc., but also our feces and urine and those of animals, particularly in agricultural systems. All of this has to be dealt with, and all of it is placing an extra burden on the natural processes of uh, degradation that take place, which are established to recycle the elements on the planet. But now we are adding huge amounts to those recycling and often overwhelming them. The last one I'll mention, I'll only talk about briefly, but it's something really to bear in mind, because it is one thing that may well appear in the geological record, and that is the use of nuclear fission. This is an entirely modern phenomenon. The first atomic bomb was exploded in 1945, and it creates entirely unique radioactive isotopes, as well as increasing the amount of naturally occurring radioisotopes. And these are things which might well be lodged into the geological record for future generations to see and say, aha, something happened around about this time. The last thing that I will discuss in any detail is mining. And this is a particular interest of mine. Mining is both, we mine for fuel sources, coal, and for oil, etc., but we also have mining for chemical resources. And mining is an extremely destructive undertaking, which we'll discuss in a little while. And the other, we have discussed global biodiversity reduction and collapse. And I've also mentioned before our misuse of our freshwater resources. We'll refer briefly to that again. Okay, so let's have a look at what happens with urbanization and the development of cities. Now, these began very early on in the agricultural period. If you go back to the previous lecture, you'll remember that agriculture developed in the Fertile Crescent of the Middle East and Levant. And one of the impacts was that people gave up nomadic lifestyles and began to gather together. There was tremendous advantage to that, because at the same time as agriculture was developed, human conflict began to increase. So gathering together in a large group like that afforded protection. But cities and gatherings of people are also engines of tremendous creativity. Within those cities, you develop classes of people who are not agricultural. Instead, there are civil servants, merchants, etc. And also, it has to be said, artists, musicians, people who entertain other people, etc. All of these very human pursuits become amplified. And it's within those early cities that mathematics was developed, early science began to be studied, etc. Often for a purpose, to predict weather, to predict a crop, when crops should be planted, when they should be harvested, etc., etc. But nonetheless, these were the bases of the same technologies that we now employ. So those are good. So then you can probably think of other advantages of being together in the city, but it also brings with it these tremendous problems, and cities have an enormous ecological impact. They attract huge numbers of people. As people abandon, as people see an opportunity for earning money, for example, within a city, they abandon agrarian lifestyles and they begin to flock into the city. And the city grows, and it grows at the cost of the environment around it. And because there's a huge impact on the environment as the habitat is destroyed, as the habitat is destroyed, biodiversity begins to decrease. In addition, the city produces a huge amount of waste, and waste disposal becomes, in many cases, a limiting factor for cities if they are. And historically, it has limited the size of cities. People simply couldn't live there because of the waste problems. And this was fairly recently, in fact, the case in large cities such as New York and London, etc. People could not bear the horse manure when horses were the only form of energy for transport. There were huge numbers of horses, and horse manure became their global warming, if you like. That was their huge problem. Of course, now completely forgotten about. But in addition, human waste has to be disposed of, and solid wastes have to be disposed of. The trash that that people produce. There's one other aspect of cities which is very important in climate, and that is that cities act as heat islands. Because the natural vegetation is lost, cities are built of initially stone and that sort of thing, but now, of course, of cement and asphalt, paving, etc. And these materials absorb heat. They absorb a tremendous amount of heat, and they re-radiate it out. So, for example, at night, cities can be up to 5 degrees warmer than the surrounding countryside, if not higher. And especially with global heating, this has become a huge problem in cities. For example, we're already seeing heat waves which persist in cities and approach the limits of human habitation. They approach the limits that humans can actually survive, especially when this heat island maintains heat at night. So this may, in fact, end up being a limiting factor in cities in how big they grow before they have to really do something about it. So here, for example, is this is an informal settlement. This is not regular kind of building and everything. This is Makoko in Lagos in Nigeria. And I show you this for a particular reason, and that is we're going to discover that the fastest growing cities are actually in most of them in Africa. And Africa is going to be, we're used to thinking about Asia as being the great growth center of human population. In actual fact, that is moving now to Africa. And Africa is beginning, especially Central Africa, south of the Sahara, the cities are beginning to explode in size. So you can imagine all of this formerly was forested. That has all been cleared, and it has been replaced by these informally built, usually built of corrugated iron, that sort of thing, these houses. But they unfortunately have no sewage, no running water. When it rains, you can see what's the, don't forget, this is an equatorial region, so it rains a lot. They flood, and of course, these floods are full of sewage, full of human waste and animal waste as well. Many of these people will, in fact, keep animals, like a cow, goats, something like that. And so these actually turn into running sewers. It's a really huge problem, and the health effects in these informal settlements are tremendous. And it's a huge burden. It becomes a huge burden on the government, especially in a developing country, to try and cope with all of the problems that are associated with this rampant, uncontrolled, unplanned growth of cities, which is typical of large cities, especially in developing countries. And as a result, these informal settlements throughout Africa tend to be centers of tremendous political unrest. These people really, really do suffer. They lead hard lives, often with very, very little small income. And so these tend to be a tremendous problem for established governments, because they are crying out for resources which is often simply not available. So here, let's have a look at the largest cities in the world. Largest city is Tokyo at the moment, 37.5 million people. And all the way down, and here's New York City at the bottom, about 18.8 million, so say 19 million. It's probably close to 19 million now. And you'll realize what it feels like to be in a big city. Those of you who are here or elsewhere living in a big city, you tend actually to make a world around yourself. And that is the natural human tendency. So, but remember that all of us are contributing to the development of the environmental problems which all cities incur. Here are the fastest growing. You don't need to worry about the numbers and everything. The map is more important. I just wanted to point out to you that here are the fastest growing cities in the world, and only 3 of them, 1 in China, 2 in India, only 3 of them are now in Asia. Formerly, this was the site of the fastest growth of cities, but now that has shifted, and look here, and you'll see that here are all in Africa. These are all African cities. And in fact, here is Mozambique. Here is Maputo. And that is one of Africa's fastest growing cities. And I will just remind you that that is very, very close. Here's another city. I'm not quite sure what this city is. My eyes aren't good enough to see on the screen. But I will remind you, this city here, which is also listed, is very, very, that and Maputo, very, very close to Gorongosa National Park, which you now know a lot about. So you can imagine that the growth of these cities begins to put tremendous pressure on even areas which are set aside as reserves. So I wanted to mention one other aspect of modern city development, and that is that the motor car has impacted the structure of cities to a huge extent. And cities actually, their expansion is often built around the motor car. And it's built around roads to transport people back and forth. And often the city is structured around road systems. And but cars in themselves are a piece of technology which have tremendous ecological impact. And the reason for that, of course, is that they produce a huge amount of carbon dioxide. They also produce nitrous oxide, by the way. And car pollution, when it sends into the atmosphere, it has other compounds, sulfur compounds, as well as nitrogen compounds, which actually end up being greenhouse gases as well. So the other aspect of car ownership is a huge contributor to the development of heat islands. You'll know that in summer, for example, you can barely walk on asphalt. It gets so hot. And then you go out at night and it feels like it's a heater. And it is. It is a heater. It's radiating out its heat, and it will do so for a number of hours during the night before equilibrium is established. And the car ownership has contributed a huge amount to habitat and biodiversity loss because it places such incredible demands for space. Road systems need a lot of space, and they are in themselves extremely destructive because, for example, they are often run through human habitation. They tend to go through the poorer areas. They break up the city. They break up the continuity of the city, even though they're there to commute between areas of the city. Just imagine you could not walk into the city from over here to there. You'd have to find some way to get transport in because of the huge freeways that act as boundaries around the city. Okay, so accepting that cities do have huge problems. The solutions lie in planning, in ensuring that cities do not just develop informally, that they actually are planned, and that they are planned with the environment in mind, as well as the human habitation. We have to accept cities are going to exist, they're going to grow, and they're going to continually attract human beings. Now we need to do it in such a way that we cause as little ecological damage as possible. And the cities now are usually planned around open spaces rather than planning around roads. They try now to plan new cities and new city areas around open spaces, parks, preserves. And this is a purely practical reason. It reduces the heat island. It reduces the amount of energy that the city demands in order to remain cool enough for people to live there happily. In addition, these parks, preserves, serve as centers of biodiversity, and they provide corridors for wildlife. For example, just imagine that, I don't know if you know, but our parks here in New York, even the small parks, let alone the big parks like Prospect Park and Central Park, in migratory season, they act as centers for birds to settle, rest, feed up a bit, and then move on. In addition, they are nesting areas and everything. So that if we have enough of these parks close by one another, they can actually act as corridors where wildlife can establish almost a natural lifestyle, and without this being wiped out entirely. In addition, it's becoming obvious that cities should not be planned around cars. They should, in fact, be planned around public transport, which is run on renewable energy sources. And this would relieve a tremendous amount of the problems that we currently have associated with the motor car. Okay, so have a look now. This is, this is a typical trash dump. Trash dumps are in themselves a huge problem for various reasons. In these urban populations, they produce a huge amount of waste. A lot of solid waste, which is just non-biodegradable, plastics, that sort of thing in modern times. But also mixed in with that, a huge amount of organic waste, food waste, for example, even things like old clothing, cotton, things which are not synthetic, which are essentially plastic, but cloth which is not synthetic is biodegradable. Cotton, cloth thrown out as waste is a huge contributor to the amount of waste that we see. Here's a person down here. This is meters thick, and these waste dumps may extend over a huge area, over many hundreds of acres. There is, quite apart from their unsightliness and the fact that they are breeding grounds for disease, etc., the one major problem with these trash dumps is that below the surface, they become anaerobic. The bacteria breaking down the organic waste use up all of the oxygen, and then shifts to another group of bacteria which are anaerobic, and they produce, as a waste product of their metabolism, they produce methane. And these trash dumps are a major source of methane, and you will remember that methane is a major greenhouse gas contributing to global warming. So these waste dumps break down extremely slowly. Now, they may take centuries to stop producing methane. You will frequently now in cities see that old waste dumps, they do not bother to try and clean them out and find somewhere else to dump. In New York, they used to dump all the stuff out at sea, which is an even worse idea. But that's no longer allowed in the United States. Instead, all our waste is taken to the landfill, And as the landfill ages, what they often do is they will come and reclaim what they, and there's a very good example of that. I think it's New York, still New York's newest park, which is the Shirley Chisholm Park in Brooklyn on the coast. And it was one of New York's and one of Brooklyn's major dumps for many, many, many years. A huge, huge landfill. And what they did was they capped it. They poured concrete over it, and then they covered it with many meters of soil, which was extracted from building areas in Manhattan, etc., where development was taking place. And they pipe all of the methane off. Now, all over the world, there are cities which actually harvest the methane, because that is natural gas. And they harvest the methane and use it. And they pipe it to industry and to households, etc. In the Shirley Chisholm Park, I don't think they do that, but you will see periodically in the park, you'll see vent pipes which actually burn off the methane. But as I say, these landfills can produce methane for centuries after they've been sealed. This is Dandora. This is in Nairobi, another very, very fast-growing city in Africa, in East Africa. So if you have a look at this, you realize also that this is a pretty loose aggregation of all this different waste. And a lot of stuff from the landfills does not stay in the landfills. It makes its way away from there, either gets blown off or gets washed off in rainstorms, etc., etc. And much of it ends up in rivers, streams, and ultimately in the ocean. And plastic pollution of our rivers and streams is bad enough, but plastic pollution of the ocean is an immense problem, because many of these plastics are simply non-biodegradable. And they're essentially there for an incredibly long time. A lot of them float, and they interfere with the organisms which live in the ocean. So here are a couple of examples. First of all, the simple unsightliness of this waste on beaches is really upsetting. Nobody wants to go to a beach like this, probably a beautiful beach under normal circumstances. But since 1950, there has been a huge globalization of industry worldwide and a huge increase in the production of plastic, often for very, very limited use, often a single use of the plastic only, then it goes to the landfill, or in cities where there's not a formal trash collection, which is the case in many, many places in the world, it simply gets dumped into a stream or a river or on a road to be washed down and washed eventually out to sea, up onto the beaches to remind us that it's there, but the real problem is that it's in the oceans themselves. Organisms in the ocean may mistake it for food. This is the case with turtles. Turtles are an endangered group anyway. But they often mistake plastic bags for their natural prey, which is jellyfish. And they will eat plastic bags, and turtles are frequently found dead on the shore. When they autopsy, they find the stomach full of plastic. And this here is an albatross. This albatross is actually a chick, and its parents have fed it plastic. Its parents cannot distinguish between floating plastic and floating pieces of food. They pick it up, bring it to the nest, and they regurgitate it and feed the chick with it. And here's a poor chick. She's died. And you can see that the stomach was absolutely full of small bits of plastic bottle caps and all of those sorts of things. And birds out at sea, feeding out at sea, will do exactly the same thing. They will feed themselves on plastic. And they die both because they clog up their digestive system, but also because they think they're full and they stop feeding. But of course, there's no nutrient in plastic. So this is a really big problem. And in the ocean, in the wide ocean, in the pelagic, the current systems pick up the plastic and tend to aggregate it. Now, the most famous one of all, aggregation of all, is called the Great Pacific Garbage Patch. And I'll remind you, we briefly looked at the structure of ocean currents, and I pointed out to you then that these ocean basins are often marked by having these circular current systems called a gyre. And here it goes from east to west, and then north and across. Now, this Pacific gyre here, it converges with the currents coming this way, and it tends to slow down here. And because it slows down, anything that it's carrying tends to accumulate. And what it has accumulated in recent times is this immense collection of plastics. Now, this is not the only garbage patch. There are other garbage patches in all of the other gyres, in the southern gyre and in the Atlantic gyres as well. These huge aggregations of plastics just swirl around and around and around. Very interestingly, marine organisms have started to colonize these, but the organisms which colonize them are organisms which normally colonize rocky shores, intertidal areas, because they regard these as being like an intertidal shore. This is not a good thing. It sounds like it's, oh, well, everything's okay, things are growing there. They're growing in completely the wrong area, and they are utilizing very scarce resources, which should be, under normal circumstances, be used by organisms which naturally occur here. And especially, this is a nursery ground where fish and other organisms tend to mature before they make their way off elsewhere to their adult habitats. And many of those are being wiped out because these huge garbage patches simply use up all the resources. Okay, so what do we do? Well, of course, the first thing we think of, oh, we'll recycle. So we'll gather up all our plastic, and we're going to send it off for recycling. And there are certainly huge efforts being made to recycle plastics, especially. Glass, by the way, is not so much of a problem. It's an unsightly problem, and it's dangerous if it's freshly broken and everything. But glass is inert, and it's actually very similar to soil. It's the same compound. So eventually it gets ground down and it can form part of the sediment. But plastics do not. If anything happens to them in the environment, they just tend, as I've told you, tend to form smaller and smaller and smaller pieces, but they're still plastic. So here's an elaborate recycling system where they're attempting to recycle as much of the plastic as possible. But unfortunately, recycling so far in the world is not very successful. And so here, for example, I just need to do something here. So in the United States, we recycle 66% of paper and cardboard. That is relatively easily sorted and relatively easily recycled. And it is, cardboard can be recycled several times before it actually has to be discarded. And paper and cardboard, of course, are natural products, and they will degrade. Adding too much of them to the environment is going to cause a problem, but they will be biodegraded. Glass, we only recycle 27% of the glass, and very, very, very disappointingly, we only recycle 8% of our plastics. Most of the plastic that you put in your recycle bag is going to end up in a landfill. Very little of it can be recycled, and for very important reasons. First of all, there's many, many, many kinds of plastic. And to recycle them, they have to be sorted into similar piles. And second of all, not all of that plastic can be reused. Not all of it can be melted and reformed into another product. A lot of the plastic simply cannot be reformed in that way. And other thing, the real killer to the whole thing is that using recycled plastics now is much more expensive than using new plastics, because we have so much oil and gas at the moment. And most of the plastics are derived from fossil fuels. So it's much cheaper just to use the new plastics than to recycle old. That is the reason why. And the recycling elsewhere in the world is even lower. In the developing world, apart from what people will actually pick up themselves and reuse, there's virtually no recycling, which explains the size of the Pacific garbage patch. So one of the big problems with plastic, of course, is that a lot of it is single use. And these plastic bottles, plastic water bottles, are amongst the biggest culprits. And you'll realize when we look at floating, the stuff that comes up on the beaches, a huge number of those items are actually water bottles. And they are very, very long-lived, 450 years before they will break down. But even then, they're not breaking down in that if they break down completely, they will release carbon dioxide to the atmosphere. But they tend to just simply break up into smaller and smaller and smaller pieces and get incorporated eventually into sediments, I would guess. But it takes a long time. Plastic bag, 20 years in the ocean, floating around in the ocean. That's a lot of turtles that are going to be killed. Cigarette filters, those of you who smoke, and I hope it's none of you, you'll see people cheerfully tossing their cigarette stumps onto the beach. Those last about 10 years before they fall apart, but the plastics included do not necessarily break down once the filter has fallen apart. Styrofoam, there is no estimate on how long it lasts. The styrofoam itself will break up. You probably know styrofoam is like little balls that are all stuck together, little balls of foam that are all stuck together. Eventually, those balls all separate, but there is no estimate on how long they effectively they live forever. Coffee cups, plastic straws, 200 years. Cutlery, 100 years. This is plastic cutlery. Look at this. Where do these come from? These take out food. People stock up on takeout food the whole time, throw away their containers, etc., and many of them end up in the ocean. So what are the solutions to this? Well, the first is to severely restrict production and to make it expensive. Make the objects expensive, and use will decrease and reuse will increase. Second of all, put high deposit prices on it so that people using it, handing it back in to get their deposit back. And then it can enter an official chain of recycling or reuse. Put taxes on articles, again, that goes to making them expensive. Put taxes on articles, people restrict their use. One of the big problems that we have is that this stuff is so cheap. It's just so cheap we can just use it and throw it away. Reduce the range of plastic types. Centralize the production of plastics so that we only produce things which can be recyclable. Then move into the market of replacing these things with truly biodegradable materials. That we are seeing, that we are beginning to see, but it's a feature of developed countries and wealthy developed countries because these are quite expensive to produce. They can be reused, however, but they are eventually things, for example, that you will see, biodegradable containers using bamboo cutlery. That is quite a commonplace here in New York, and hopefully that would become generally available. We need to educate people. We need to educate people about their use of these materials and make, in the end, make people aware of the damage that they are doing by using them. But if you use the stuff, you encourage its production. If you limit your use you discourage production. The other, like, physical things to be done to attempt, especially to stop pollution, ocean pollution, is to trap plastics before it gets to the ocean. And I have personal appeal to you all. Please stop using glitter. Glitter is a major problem. It is a microplastic, and it is now found in all of the world's oceans, from the surface of the oceans to the very depths, and it is turning up in Antarctic snow. It is also present, glitter is also present in the flesh of most fish that that are caught. It is an iniquitous substance and extremely difficult to clean up environmentally. The other thing with balloons, I want to have a fit every time I see a funeral where they release balloons. The balloons do not go to heaven. Balloons released at a funeral are blown out to sea. They eventually deflate, fall into the ocean, and they choke something to death. So if you have the unfortunate task of organizing a funeral, please do think of something else. Throw flowers at one another or something. Don't release balloons. Okay. So this topic I'm only going to mention very, very briefly. And that is the issue of nuclear waste and nuclear pollution. Now, nuclear fission, the process of nuclear fission, is a natural process. It happens in the sun, etc. It also probably happens in the center of the Earth, by the way. But man-made nuclear fission produces a lot of strange, abundant, very, very long-lived radioisotopes. And many of them are unknown in nature. And when I say that they are long-lived, they have a half-life. They will decay to half of their amount in millions of years, some of them. So these, once they enter the environment, nothing is going to break them down. They have to break down on their own as radioisotopes. And they are found ubiquitously everywhere. We even in our own bodies carry radioisotopes which derive from sources of nuclear fission. And there are two major sources. The first are nuclear explosions and the bombs. And the first bomb was those of you who've seen Oppenheimer will know, was exploded in 1945. And since then, there have been numerous nuclear explosions, controlled nuclear explosions, although most of them are done underground. Still, when they are done underground, the radioisotopes can enter water courses and make their way to the environment. And indeed, they do. The other source, of course, is controlled nuclear fission. For instance, in power plants, nuclear power plants, and that sort of thing. But also for the production of industrial and medical isotopes. So there are many, many sources of these radioisotopes that are completely artificial sources. And I mention this in particular because it's one particular thing which is important maybe important in establishing the Anthropocene, because future geologists and paleontologists looking at our sediments laid down in our time will see that suddenly these strange isotopes and sudden increases in naturally occurring isotopes will occur, all associated with our production of them through nuclear fission. And some people say that this would mark the true origin of the Anthropocene, that the true Anthropocene would begin in 1945. So let's have a look now at our we've talked a little bit about ocean pollution, but let's have a look at our actual exploitation of the ocean, because the ocean has been the oceans have been radically overexploited, as I'll explain. Now, since the earliest times, human beings have used the oceans as a source of food, and it's fish and shellfish. They will also use the oceans as a source of salt. And of course, they have been tremendously important for transport. Since the earliest humans, we believe that they very soon developed primitive ways of using the ocean for transport. And here is an ancient, this would be probably, I would say 18,000 years old or something like that. And this is in Africa. And this is a midden from the San people. And you can see the shellfish here are all modern shellfish. I mean, they still occur on the shorelines. And they're things like limpets, abalone, and mussels. And the people would carry them inland a little way, eat them, feast on them, and just throw the shells into these huge piles. Very, very interesting, because it gives us an idea of diet. And included in these, not shown here, but included in these, you often find fish bones, which tell us their fishing ability and where they would. And sometimes we see fish from quite far offshore in these primitive middens, which indicates that people had some means of fishing out at sea. So we've started off right at the beginnings of our existence as humans. 200,000 years ago, we were already utilizing the ocean. But we existed in balance with it because our populations were very small at that time. But with this huge increase in population, changes occurred. Right up until fairly recently, 1700s, 1800s or so, we used low technology fishing. And it was largely sustainable. People were using primitive nets, hand lines, etc., to fish. And they couldn't remove the fish faster than the fish could breed. So the stocks were continually replenished, and human impact on the stocks, the ocean stocks, was limited. But with the advent of technology, of scientific technology, we began to develop wholly industrial methods of fishing. We began to develop huge nets, which could be strung behind fishing vessels for a huge distance. We began to develop nets which could be dragged along the bottom, huge nets which could be dragged along the bottom. These are the typical, I know it's not an absolutely clear picture, but these in the background here, these are typical for a modern fish. Even a relatively small vessel can cast huge nets and end up with immense catches. But there are two big problems. The first problem is overexploitation. We simply pull out too much. The fish stocks cannot reproduce quickly enough to replenish what is taken. It is not sustainable under those circumstances. The second problem is that we do a huge amount of damage to the environment when we are fishing. There is no way to simply get the fish that you want. In these nets catch everything. And that is called bycatch. And these nets come up with a huge amount of organisms, just different organisms, all the way from invertebrates, vertebrates, turtles, dolphins, other fish, all sorts of things. There are nowadays attempts made to separate them out and cast it back, but often the fishing itself does so much damage to the organisms that they simply die. And this is particularly important in benthic fishing, where they scrape the bottom and they effectively dredge the bottom for bottom fish and pull up virtually everything that lives on the bottom. So thought I had, yes, I do. Sorry, I put those out of order. So here's a typical, have a look here. This is, I believe, a bottom trawl. They're coming up with huge amount. But have a look here, this net here, they've just pulled up a bit of it. If you look carefully here, you'll see that there's virtually nothing usable in this net, in this particular net, not this one, but in this one here. If you look carefully, you'll see these are all sharks, small sharks. This is also a bottom trawl. They've pulled up all sorts of invertebrates. They've pulled up fish which are too small to use and have been bashed around and are useless, along with the occasional large fish, which they would probably pull out and be able to sell commercially. This is a very wasteful and extremely damaging system. So there is now a lot of effort going into trying to develop new high technology netting systems which limit the amount of bycatch and which limit the amount of damage done by the nets, especially when they are bottom trawled. I just want to go back here. This is the result of overexploitation of the fish stock. This was one of the great fish stocks of the world. This is off the east coast of Newfoundland. And this is Atlantic cod. And Atlantic cod, since the 1500s, has been a major fish, a source of fish for Europe, for the whole of Europe. In the days before they had refrigeration, they would salt the cod. And those of you who like bacalhau, that is exactly what bacalhau is. It's salted cod. And salted fish was a staple protein source for people from medieval times onwards. And this was a huge tradition of sending out the cod fishery every year to east coast of Newfoundland, where they fished quite happily. You can see here, right up until about 1950, the 1950s here, the fishery appears quite stable and quite replenishable, renewable. That's the word I'm looking for. Then from 1950s on, this is the era of industrial fishing. Now high technology fishing comes in and they begin to just take out absolutely everything that they possibly can, including all the way from very large, very old fish to the very small fish. They find a use for them all. Now they have hit the stocks so badly that they simply can't breed at all. Now the few cod that there are so far apart from one another, they can't find one another to mate and reproduce. They don't mate, actually, they release their eggs and sperm into the water, but they have to be close to one another in order to do it. As a result, the cod fishery collapsed completely, absolutely completely. As soon as possible, they put brakes on and wouldn't allow fishery to occur. But as soon as the stock began to recover, and as soon as it got back to more or less what it had been before industrialization of the fishery, they began to hammer it again. As soon as fish were available, they hammered them again. And finally, in 1992, the fishery collapsed absolutely, completely. And since then, it has begun to come back now, but a moratorium is still in place so that to try and reestablish. This is typical. This is absolutely typical of the overexploitation of ocean resource. Now I want you to think back. Think back to your trophic cascades classes, right? We talked extensively about the impact of removing members of feeding of a food chain, removing significant member of an ecosystem. That is what has happened here. And this has had ripple effects throughout the entire ecosystem because we've taken out a major, major predator from the system. And this whole system has restructured. And once it's restructured, it's very difficult now for the cod to reestablish itself, even if it begins breeding. So it'll be a long time before we restore the ecosystem to the state where we can begin to exploit the cod once more. A very sad story. And it's a story, unfortunately, which is repeated over and over and over and over again all around the world. As soon as they find a good fishery, they seem to rush at it and just overexploit it. Despite all the lessons of the past, money is the great determinant. So here's another problem associated with fisheries, and that is a lot of these nets, first of all, are not biodegradable, and a lot of them are lost. And this is called, many of them will float at some depth. They don't necessarily float on the surface. Many of them find a depth at which they will stay, and they will simply move around with the ocean currents for decades. And as they go, of course, they catch things. Other things become entangled in them. Here's a poor seal with a piece of netting wrapped tightly around its neck. But the nets which float are called ghost nets, and they catch virtually everything that attempts to pass through them. And these are very typical victims: turtles and sharks. Sharks are a tremendously important member of the ocean ecosystems, and they are being decimated, both deliberately, because they're exploited as a resource, but also by these ghost nets. You can see this ghost net is made of plastic, and it's floated around for a good long time, and it's caught on all of these organisms. Once they're caught, they simply drown. So what are the solutions? Well, first of all, is to institute strict controls. But you know, it's very, very difficult to control what a captain does out at sea when there's nobody to see what they do. And this has always been a huge problem. To post inspectors on the ships is one solution, and that is done. But it is very, very, very difficult to have an inspector on every single fishing vessel. There are hundreds of thousands of them out at sea right at this moment. It is really important that we gain knowledge about the organisms that we're talking about, and that the fishery be based on science-based fishing quotas, strictly enforced, to ensure that we keep it in the sustainable levels. We have to put moratoria on endangered stocks like the cod, but many other fisheries as well. We need to have a strict moratorium, no fishing of those fish at all, to give them time to recover. And especially important in this regard is to establish worldwide marine preserves. And when I say worldwide, what I mean is that we should establish marine reserves which are close enough to one another that they can communicate, so that there are huge areas of the ocean which are no-go areas for exploitation of any kind. And those afford those stocks a place where they can recover. And especially they are areas which can act as nurseries, where juvenile fish can grow up and become mature before they start moving out into the wider ocean. We need to have high-tech nets of various kinds, but especially biodegradable nets. And those nets, we have the technology to do it. Those nets should be identifiable. And they should be identifiable to specific companies. So that if a ghost net is discovered, that company is penalized, and penalized heavily. Do that, and they'll pretty soon start developing methods to prevent the establishment of ghost nets. Instead of simply cutting a tight net off the ship and letting it fall away, they will pretty soon develop ways of recovering nets, even if they are damaged. Okay, so, you know, the fisheries in the oceans are often referred to as ocean mining. That we simply go out there and we just rip out of the ocean what we want, and damage be damned. Real mining on land is pretty much the same. Mining is one, in general, it's one of the most damaging human endeavors. And of course, we have mined the earth since very, very early times. The Iron Age already established mines to mine iron ore to use, but those were small scale operations compared to the mining that goes on today. So I'm using here an example. This is in West Virginia, and this is a problem throughout the Appalachians because the Appalachians are very, very rich in coal, all the way from Ohio, West Virginia, all the way down to Pennsylvania, are very, very rich coal seams. And I'll explain that coal is originally laid down like that. But this is an area of mountain folding. So the mountains formed like this, and the coal seams were bowed like that. So we end up with hills, very shallow underneath here. The coal seam lies like a cap, just underneath the top of the hill, but for a considerable depth. And this is the origin of the clear cutting and the open cast mining, which is very prevalent in West Virginia. And here we see an area. This is before. Look at the little blue dot. There it is there. There's the blue dot there. And what has happened is that they've come along to this hill area here. They have clear cut the forest, which is a problem in and of itself. And they have then started to scalp the hill, literally tear off the topsoil, and then mine the whole area to extract the coal. And this is called open cast mining. And it is a particularly damaging form of mining because it disrupts the entire ecosystem where it's sited. Now, I just point one other thing out to you. In all of these little valleys here, there will be streams. Water will flow down these little hills into streams and gather into rivers below. This open cast mine, therefore, is in close communication with streams all the way around. There is a huge problem with the amount of waste, rock waste, that these open cast mines produce, and they have had permission to throw that waste into these valleys in order to get like a landfill almost. That was restricted for a long period, for about a decade or so, but in the last, not this current administration, but the last administration, many of those restrictions were lifted. And we're back again to them throwing this waste into these water sources. So you'll see the big problem in a minute. This is not just ugly, this is extremely damaging. And it is they nowadays have a requirement that they're supposed to restore, once the seam has been used completely, they are supposed to restore this, but you can tell that this would be an almost impossible task. So here is a typical open cast mine, and you can see why I say it's almost impossible task to restore that afterwards. This is a problem. This is the coal itself. Here's the coal bed here. And remember, it goes off around the side. So this is a very large area. And this is an extremely, still a very valuable resource. Remember that coal is one of the major fossil fuels, which we use as a source of energy. So here is what I meant about the rivers and streams. Here's a mine here. All of these here, you see, this is a road here, and the road here. But all of these other little white streaks here, these are all rivers. And not only is the waste tossed into them, but there is another major problem with these mines. And that is that the coal all over the world, doesn't matter where you are, coal is very rich in sulfur and in sulfur compounds. And often associated with it, there is iron, and iron plus the sulfurs that are present form an iron sulfide, which forms, you probably all know, iron pyrites, which is fool's gold. It looks metallic, and it's a bright gold color, very pretty when just look at it. But this iron pyrite is only stable under anaerobic conditions. As soon as it gets into the air and is associated with water, it very quickly breaks down. And it forms first of all iron hydroxide, which is a bright orange color, and it forms sulfuric acid in the water. And these mines, these coal mines, tend to leach water. Rainfall and everything fall on them, and it percolates through, whether it's a tunnel mine or an open cast mine. The water seeps through the different layers and then emerges in springs and everything else to enter the water, to enter streams and everything else. Those passing through these coal layers, they degrade the iron pyrites and they emerge very rich in the sulfur ions, which forms sulfuric acid, and in this iron compound. And here you can see here, this is referred to as acid mine drainage. Here a typical acid seeps from mines. The orange is this iron hydroxide. And the iron hydroxide, it will precipitate out and completely smother the bottom and kill obviously all the organisms. But the organisms in the stream cannot survive anyway, because the pH is so low, the acidity is so high, that this is almost pure sulfuric acid sometimes. And this is a very, very big problem, because it degrades all of the water courses that this passes through and is basically sterilizes streams as it goes. And these mines can leach this for hundreds and hundreds of years. There are, in fact, Roman mines in Europe, which are thousands of years old, which are still leaching acid water from them. This is a huge problem. So in developed countries, there are very strict environmental regulations, there's very strict permitting, regular inspection, and requirements that they put in systems to prevent damage, to prevent seepage, and also that they treat this water, they treat the acid drainage. We still have thousands of old mines which nobody owns anymore, which are doing this. And that becomes the responsibility of local government in order to remediate the whole system. And I think I've put a little movie in for you, a little short movie on how this water is treated before it can be put back into the river systems. But these problems pertain worldwide. And it's only in developed countries like the United Kingdom and Europe and the United States where these strict mining regulations are put in place. And even then, money talks. And many of these mines manage to persuade local politicians to look the other way when they skirt the regulations, I have to say. Okay, so the other way in which we are impacting our environment is by changing natural biogeochemical cycles. Now, I need to just tell you, don't freak out at these diagrams. I simply want to explain to you that there are two elements which we are particularly interested in, and these are nitrogen and phosphorus. And the reason for this is that these two elements are often limiting elements. They are in under normal circumstances in the environment, they're in relatively short supply. And if you remove them, if you lower the concentration, then vegetation especially starts to suffer. But under normal circumstances, there is a natural balance to supply enough of them to normal soils and everything to keep the plants growing quite happily. So I'll explain it very broadly for you. The nitrogen cycle depends upon nitrogen, the gas. Our atmosphere is full of nitrogen. Most of our atmosphere is nitrogen, but it's in the form of this of two nitrogen atoms together, and it's almost inert. It's very no biological system except for one can use atmospheric nitrogen as a source of nitrogen. Nitrogen is incorporated into all proteins, especially, and our nucleic acids in living things. So it's a very, very, very essential element. There are, however, microbes which can fix nitrogen, and they can turn atmospheric nitrogen into a usable product, which then enters the biological cycles. Plants take it up, plants grow, plants are eaten, of course, and the things which eat them die, and they also produce waste. And so that death and waste, that gets broken down, and it re-enters the soil, and those things then contribute back. They contribute to a cycle, continuing to provide nitrogen for the plants, etc. But there's one group of microbes which can break down these nitrogen compounds, and they turn it back into atmospheric nitrogen. We also have a source of fixed nitrogen in lightning. That comes down with the rain and contributes as well. Over the geological time, we established a balance, and as much enters the soil, leaves the soil, basically. So we always have more or less the same concentration of nitrates, and ecosystems adapt to the amount of nitrogen that they have available to them. And that's over eons. Now we come along, and we've developed a system to actually make our own usable nitrogen compound from atmospheric nitrogen. And with doing that, we produce masses and masses of our own fertilizers. And we use that widely. We use it in farms, grow crops, etc. We use it in home and garden to grow our gardens. And almost everybody who uses it overuses it. Almost everybody puts much more than is actually necessary, because a lot of it is going to be washed away. It's going to dissolve and be washed away. But that's what we need to think about. Because where is it going to be washed to? It's going to be washed through soils and destroy the balance. It's going to add far more nitrate to the soils than is necessary. But very importantly, it's going to end up in water. And it's going to end up in the rivers and ultimately in the sea. And it's going to destroy this balance, this biogeochemical cycle balance. And that's going to have some really bad effects. Much the same thing is true for phosphorus. But phosphorus is not a gas. Phosphorus is a solid. And most of the phosphate, we use it, it's used biologically in the form of phosphate. Most of the phosphate is bound up in rocks, and it's washed out very, very slowly and made available to living things, to the plants starting off, and then to other living things very, very slowly. But again, there was a balance. As much is taken, enters the soils, is actually lost from the soils and ends up back into the sediments and ultimately will form rock. We have, in growing crops especially, we have an insatiable need for phosphorus. It is, again, a limiting compound. So if we want to grow rich crops at a huge rate, we have to supply phosphorus, and we oversupply the phosphorus. And we get the phosphorus, by the way, from rock. Here, these are phosphate deposits here. And we mine it, process it, and then spread it freely on the fields and everything else. And again, it ends up ultimately in the watercourses and ends up ultimately in the ocean. So we disrupt this balance as well. So this is the effect. Once these nitrogen and phosphorus enter the water, they disrupt the ecological balance because they encourage small plants, planktonic plants, the algae and things like that, to grow, and to grow in abundance, to grow far faster and far greater biomass than would normally be the case. And this is I'm using fresh water here as an example because it's easy to illustrate. But you can see here, it forms these thick scums on top of the water. But these scums are actually so thick that they shade the plant, the algae underneath. And the algae underneath, starved of light, actually die. And they become deprived of, then those waters become deprived of oxygen. As they decay, the bacteria that break them down use up all the oxygen. And they suck up all the oxygen, turn it into carbon dioxide, and the water becomes anaerobic. And nothing then can grow. Nothing can survive underneath these. It becomes a poisonous brew of stinking, dying algae with a thin layer of algae on top, which shade everything else underneath. And this is the process called eutrophication. And it can end up producing huge fish kills. Here you can see here, this is a fish kill which has resulted from oxygen being entirely removed. But I've used here fresh water as an example. But the same thing happens at sea, but at sea, it happens on a vast scale. And for example, in the Gulf of Mexico, it produces huge areas of oxygen-free water, which are called dead zones, because nothing survives. Nothing survives except bacteria in those dead zones. Fish die, everything migrates away if they possibly can as the oxygen levels drop. But fish die, of course, dead fish are going to add to the problem because they're going to be decayed. And in addition to that, these situations of high nitrogen, high phosphorus also encourage the growth of poisonous, toxic organisms, especially in a group of bacteria called the cyanobacteria. And those can actively poison animals, birds, humans. This is a situation which now occurs almost every year in Florida. And this is not the result of farming in Florida. It's the result of people growing grass grass lawns in front of their houses. And they smother it with fertilizer so they can show off their lawn to their neighbors. And a lot of that fertilizer runs straight off. And in Florida, it's not a long distance to the ocean. And they have tremendous problems every year with these situations of eutrophication. So the solutions, of course, are first of all to address the overusage of these fertilizers and to educate people who are using fertilizers to use them, if possible, not to use them at all, to develop organic farming or organic gardening methods so that they don't avoid synthetic fertilizers entirely. To reduce the amount and instead to rely on natural fertilizers like manure, those sorts of things, which have their own problems, but tend to be incorporated into the ecosystems much easier than these artificial fertilizers. Second of all, you need to manage the runoff and treat water before it enters the natural water courses, especially before it gets to the ocean. And educate people. There is a worldwide movement now to educate people to not require a lawn to be planted in front of their houses. Instead, plant wild indigenous flowers or something which are water-wise. They use much less water. They don't require fertilizers, etc. And in addition, you can grow insect-friendly plants which encourage the natural populations of insects to reestablish themselves. Okay, so we're going to move on now to having talked about the use of fertilizers, etc. Now let's have a look at the problem of deforestation, because in the worldwide systems of utilization of carbon, deforestation is one of the most important features. you know that much of the problem of global warming, global heating, is because of accumulating carbon dioxide in the atmosphere. One of the ways in which we can successfully remove carbon dioxide from the atmosphere, one of the ways our biosphere normally does it, is in these dense, huge forests with immense amount of plant material, which is composed of carbon compounds which are derived from carbon dioxide during photosynthesis. So we need to think of these forests as being as being carbon sinks. At the same time, remember that they are biodiversity hotspots. There are many, many, many species here, many of which we just simply do not know about, have not identified yet. But unfortunately, these forests are also areas which supply provisions for human beings, especially timber. But we also use them for many of the plants as medicinal, as a source of medicines. In addition, these forests worldwide are of huge cultural significance. Many of them harbor indigenous groups, of very small indigenous groups, which are entirely dependent on them, and which are part of the human family and an important part of the human family. Destroying these forests removes the carbon sink, has a spectacularly bad effect on biodiversity. And also, in the end, we lose all of the ecological provisions the ecological resources that these biomes can provide us. So I wanted to show you, this is by the way, this forest, the natural forest in Brunei, in Indonesia. And I put it there for a particular reason, because these forests in Indonesia are coming under especial pressure, as I'll show you in a minute. It's not only the rainforests that are being exploited and cut down, by the way. It's also temporary. We in America have done a very bad job of conserving our forests and continue to exploit trees which are thousands and thousands of years old, and we exploit them for their timber. So that is the first thing which hits these forests, whether they're rainforests or temperate forests. They are great sources of wood, and wood is very, very popular building material. And so many of them are overexploited. And we cut down the very big trees, the old trees, because those are the biggest and provide us with the most wood. The second thing is these forests are often the site of rich mineral deposits, and mining takes place inside the forest, and it brings with it all of the problems that I described to you for mining before. They clear cut the forest to establish the mine. They sculpt out the geology to extract the ores, etc., etc. But the most damaging thing of all in modern times is the exploitation of forests for agriculture. And in order to do so, the forest has to be cut down. The most damaging at the moment, particularly in the Amazon and South American forests, is cutting down the forest and replacing it with grassland for beef or for growing soybean. So there's something to say about this. And that is that the forest soil, the rainforest soils are very, very poor in nutrients. The way this abundant biomass is maintained is they have very tight recycling. But this has been established through the thousands of different species that exist there, which confers stability on the natural forest. Once you clear cut that forest and put down a crop, the crop very soon uses up the available nitrogen and phosphorus. And in order to carry on the crop, you have to then use abundant fertilizer to keep them going. And this completely changes the nature of the soil. And it becomes if we stop farming, it becomes very, very difficult to reestablish forest because the nature of the soil has changed so radically. In addition, once you clear away and start using it for beef or whatever, the soil is degraded to such an extent that it gets replaced by grassland. Now, if you're growing beef, you might think that that's an advantage, but often it is replaced with unpalatable grasses. And we end up replacing one biome with an entirely different biome. And the original biome cannot reestablish itself. In addition, especially in the Amazon, what has been happening is, as you reduce the amount of forest, the rainfall drops because the plants transpire water vapor and they continually pump water vapor into the air, which is one of the reasons why these forests actually receive so much rain. Take away the forest and the amount of rainfall decreases. And pretty soon, drought sets in. And this is exactly what is happening in large areas of the Amazon at the moment. There has been drought. And because there is a drought, there have been huge wildfires. And the forest now is being burned out by these wildfires. And what does it get replaced by? It gets replaced by grassland. So we're entirely changing the nature of the whole biome. So here's a graph of deforestation, the rates of deforestation in the Amazon. And I will just tell you that each peak here is usually a period of political instability or an extremely right-wing government. And they tend to have a bad attitude towards environmental issues. This here is the latest bad attitude towards environmental issues. And this is, never mind, I'm not going to go into the politics of it. But in any case, this was a period when large number of the regulations established here, where you see decreases in deforestation, those were lifted and you can see an increase there. These decisions are very strongly tied to economic and political issues. And the Brazilians, for example, quite rightly say, why should we preserve the Amazon and not derive any income from it when you, in the rest of the world, you have long since got rid of all your natural vegetation and everything, and you are exploiting it. Why now can't we do the same? So from that has arisen this concept of actually paying the world to pay for these kinds of areas and to pay in various different ways, but to reward these countries for providing the world with this resource, this tremendous resource, first of all, of acting as a carbon sink. We should actually pay for that. Those of us who overproduce carbon dioxide, we should pay these countries for acting as carbon sinks. And they would soon stop the decimation of these forests. So here's the next major problem. And this applies in tropical areas all over the world. This is starting, but it is a particular problem in Indonesia at the moment, which is why I showed you that Brunei forest at the start. And this is to grow one particular crop, and this is palm oil. There are actually a couple of different kinds of palm that will produce oil, but essentially this is a monoculture. It's just one species being grown, where before we had this huge biodiversity in the tropical rainforest. It is replaced. This here is an area of Indonesian rainforest which is being cleared for palm oil plantation. And you can see what they do. They literally rip out the forest completely. They then plant these thousands upon thousands of palm plants. And the reason that they're doing this is palm oil is extremely valuable. And it's valuable because of the nature of the oil. The oil does not oxidize. It doesn't go rancid. And as a result, it doesn't degrade. You can make a product with biscuits, cookies, whatever, and they last a very long time on the shelf. And that is hugely valuable. It saves the manufacturers an enormous amount of money. because those things remain sellable. The sell-by date is far in the future compared to what happens if you use another source of vegetable oil, like canola oil or even coconut oil. Second of all, the palm oil is very lucrative because most vegetable oils you only get from one source, either the fruit or the kernel. But in palm oil, you get from both. You get oil from the fruit and you get oil from the kernel. And this makes it very, very profitable. And currently, about 35% of vegetable oils worldwide that are used are palm oils. And there's many other vegetable oils that are used. 35% currently are palm oil, and that is increasing year by year. And believe it or not, you may not know that you ever do it, but worldwide, each of us consumes about 7.5 kilograms of palm oil a year in the products that we eat. And if you want to know why, then have a look here. Have a look here and you'll see some of your favorites. And 50% of all packaged food now contains palm oil. Here's the one I always emphasize because this is one of the major ones. This is one of the major sellers worldwide, and that's Nutella. But many of these, there are just hundreds of products, thousands probably, that contain palm oil. And it's also used in other things. It's used in adhesives, glues, varnishes, all sorts of furniture polishes use palm oil. And it's also a major source of diesel oil. It is processed, especially in Europe, but here in the United States as well. It is, and in Indonesia, I should say. It's processed to form diesel oil for use. You know that in Europe, the use of diesel in vehicles is much higher than it is here in the United States. So I've given you a link here. This is not included in your exercise. This is just for interest if you want to have a look how to avoid palm oil. But there are moves now to try to put palm oil into a controlled situation to make the palm oil farming sustainable so that it replaces forest, uses as little forest as possible, etc. So the consequences of deforestation. Oh, I'm sorry, I meant to point this out. I think this is the saddest picture of deforestation that I have ever seen. And this is in Indonesia. One of the huge problems of deforestation in Indonesia is that these are habitats for orangutan, which are a highly endangered, very close relative of human beings. And this is an orangutan engaged in battle with this horrible machine that is busy destroying its habitat. I will tell you though, apparently this animal was part of a family group, and they were actually captured and successfully relocated to a reserve somewhere. So it did have a happy ending, but it's a very sad picture indeed. So the first thing, of course, the consequences of deforestation, first of all, is just the habitat destruction and degradation. And it just reconfigures the entire ecosystem. The entire biome is reconfigured with all the attendant biodiversity loss, major alterations of the soil and soil degradation. And as I told you, the clearing in the Amazon is busy converting that rich biodiverse biome to grassland and decreasing the rainfall, radically altering the entire climate. And the burned areas, this just becomes self-perpetuating. The burned areas are continually replaced by grassland. So this is a very, very sad situation. But there are solutions which worldwide, which are the concern of global attention. And these are to establish large forest preserves that are supported by international funding. For the very reason I told you, these areas are providing an ecological service to mankind, in particular because there are such huge carbon sinks and it is other countries which are producing the most carbon dioxide, those countries should pay for the service of the countries that are able to have their biomes act as carbon sinks. They need, however, very, very vigorous policing, especially because of illegal logging and illegal clearing for mining and for agriculture. And unfortunately, these are often the province of organized crime, also bad political actors. So this is a very, very complex issue to actually manage. Some of these forest areas can be restored. It can become very, very difficult if the soils have been degraded, but nonetheless, some of them can and have been. We also need to educate people, especially about things like palm oil. And in the palm oil issue, there is a group, a board, who will certify farms and production of sustainable palm oil. And where possible, you should always use sustainable products, of course, and especially sustainable palm oil. But probably for the most important thing we can do is to encourage people to move off meat-based diets and more to plant-based diets. Now, I know that soybean growing is one of the things which is resulting in deforestation in the Amazon. But soybean can be grown in many places. And plant-based diets in general are far less environmentally damaging than meat-based diets. And the beef farm is the major impact in deforestation these days. Okay, so that was a long lecture for you, and I'm sorry, but remember that I've only just covered the surface of it. And so what I'm going to do now is ask you please to do the exercises. Most of them are reviewing videos. I've kept many of them short. I've put some longer videos there if you wish to watch them. But I have set a number of short videos, and then there's an interactive exercise and a simple discussion for you. And those are all due after the spring break. And I certainly wish you all a very happy spring break. Use the time though. Don't just go lie on the beach. Do your spring break, traditional spring break lying on the beach. You can do some of your spring break, but also set aside some time to catch up where you need to catch up and to put some effort into what you need to submit straight after the spring break. And I will see you in 2 weeks.